everyone doing? Yeah, that's what I like to hear. My name is Kelly Sutton. As Alan said, first off, a big thank you to Alan and Leah and everyone who helped organize this conference. I know a lot of hours go into things like this, and they can be thankless jobs at times, but thank you very much for having me here. The title of this talk is Taming Monoliths Without Microservices. Before we get into the talk, I want to tell you a little story about a nun and the police, and a little story about naming things in software. Naming is hard. So I grew up in Everett, Washington, which is a blue-collar suburb about 30 miles north of Seattle. You might say, Everett, Washington, I've heard of that. That's where the largest building in the world is by volume. And you would be correct. It's a big Boeing factory. So when I was growing up there, I went to a little elementary school called St. Mary Magdalene School. This is a Catholic school, grades kindergarten through 8th grade. And like many Catholic schools, there were a few nuns, I guess, employed there. And this was, after the time where nuns would rap on your knuckles if you were late to class or talking in class or something like this. But, a few of these nuns, you would wish that they would rap on your knuckles based on the just icy stares that they would give you when they would catch you doing something wrong. None was stricter than Sister Cabrini, a 3rd grade teacher. So when I was in 3rd grade, this was when Windows 95 machines were just showing up. So a few classrooms got Windows 95 machines connected to this thing called the internet. Not sure if you've heard of it. So Sister Cabrini taught 3B. I was in classroom 3A, 3B. The classrooms were separated by a little bit of a distance. But I had grown up around computers. I think my dad's first computer was like an 8086 that I would play around on. I learned how to operate a computer before I learned how to ride my bike without training wheels. The rest of my life is just kind of filling in the blanks. And so I became known as like the 3rd grader who kind of knew how these computers worked sometimes. So one day I was called into the principal's office in 3rd grade saying Sister Cabrini has a very serious problem with her computer. She's worried that the police are going to show up. I didn't have like that much self-awareness as a 3rd grader, but I knew that this was pretty extraordinary. So I walk over to 3B. I get a hall pass. I get a walk over there. It's maybe like a 3-minute walk. 3B was in these kind of like modular buildings that were out in the parking lot. And I walk into the classroom, and I see Sister Cabrini, this very strict nun in a state I've never seen her before. She looks a little shaken, visibly. I believe the nomenclature today is shook. She was shook. She just says, I don't want to go to jail. I don't want the police to come take me away. So here's Sister Cabrini, a woman of faith, a woman who's probably never broken the law in her life, probably never even thought of breaking the law in her life, thinking that she's going to go to jail. She says, can you take a look at the computer? So I walk over to this Windows 95 computer, and there's a little modal dialog on the computer, which says, Internet Explorer has encountered an illegal error and will shut down. If you've ever used Windows 95, it's like muscle memory. When you see that, you just click OK and you restart Internet Explorer. And I had to explain to Sister Cabrini, you're not going to go to jail. This is just how computers work. But I like to think of that story because it's a very powerful story about naming and kind of I guess like the discipline that we apply to our craft sometimes. I've named things terribly, especially error messages, right? That poor Microsoft engineer in 1994, as they're rushing to meet that deadline for Windows 95 probably didn't think twice about that error message. In the context of his or her job, an illegal operation makes total sense. In the context of a everyday person or a nun, you do not want to be doing things illegal. So that's kind of what this talk is about. It talks a lot about, we're going to talk a lot about pulling apart Rails monoliths and talking a little bit about microservices and maybe how you can tee up turning your Rails monolith into microservices, should you so choose. But I think at the end of the day, it's really talk about naming things and understanding that the same name or the same word can have different meanings in different contexts. So let's get into it. First, with a little bit of audience participation. How many folks here work on a Rails code base that is more than a year old? Raise your hand. Leave your hand up. The Rails code base is more than 3 years old. Okay. 5 years old. 7 years old. Okay. 9 years old? Wow. Let's go with 12 years old. All right, you in the back. How old is that Rails code base? Wow. Yeah. So this talk is very much about these like large old Rails code bases. The Rails where it might be considered legacy software. I think that's pretty cool. Ruby apps and Rails apps are now considered legacy code. Rails was invented because Java was legacy code, and we were going to figure out all of those problems that Java was causing. So let's dive into it. Here's the structure of my talk. I'll tell you a little bit about myself, a little bit more than I already did. We're going to go into 2 stories about 2 different teams that tried to break up their Rails monolith. Finally, I'll end with a few concrete tips that you might be able to employ at your day job when you go into work on Monday, and then we'll do a little wrap-up. So, like I said, my name is Kelly Sutton. I live in San Francisco with my fiance. We are getting married in August. We're going to have a Twin Peaks-themed wedding. We live there with our dog, Greta. If you're a human being with a pulse, you probably have not listened to the last 20 seconds of what I've said, and you're just wondering, tell me more about that dog. So let's talk about Greta. Greta's a very fashionable dog. She likes to keep up with all the latest hairstyles. Recently, she got an ombre haircut. Greta's also a very well-traveled dog. She likes to bring back an item of clothing from everywhere that she visits. So here's her in a kimono from Japan. All right, well, enough about dogs and nuns. That is not why we're here. We are here to talk about Rails apps that push the limits. Oh, this is going to work. Not quite getting a reception out of my remote here. Sure. It's an older model. Okay. Let's try that. Okay, cool. We're here to talk about Rails projects that push the limits of the Rails framework. I think Mott said earlier today that Rails is great and Ruby is great for starting off projects. And what happens when you have a Rails app that is 13 years old? How does that start to change some of the things that you might normally do in a Rails application in a Rails ecosystem? So a little bit of context. I work at Gusto. We are a payroll provider. We also provide benefits and HR to small businesses in the United States. Currently, we're responsible for about 1% of the United States payroll. We move about $1 billion per month, and we're responsible for about 0.1% of the US GDP. I used to have more hair. Starting to lose it. But we do all this with the Rails framework, right? Payroll is particularly complicated if you've ever gotten the chance to work with it. Payroll combines these 4 topics of time, geography, money, and people. I think if you're building a system that interacts in depth with any one of these 4, it's going to be a very, very complicated system. Payroll is a combination of all 3, or all 4 rather. You need to know how long people are working, where they are working, how much they are getting paid, and by the way, humans are operating the system. So while you are in control of people's livelihoods, you also need to be able to reverse any mistakes that you make. It's very, very difficult to get right. So that's why we have a mantra at Gusto where we say correctness is more important than performance. We do not have the scale problems that you might see at Twitter or some other big data company. We can probably, I think I've done the math, and you can probably run the entirety of the United States payroll using the largest Amazon RDS instance. Right? It's very high density work. A single database row gets you paid for 2 weeks. But you only do that 24, 26 times a year. So this goes into a lot of how we think about how we make our technology decisions. So let's go explore some stories about what goes wrong when things get too big. So to do so, we're going to talk about breaking Monolith. So first we need to talk about the swamp. This is also known as the big ball of mud. It is that app models folder with hundreds and hundreds of active record classes. It is that Rails app that takes tens of seconds to boot. It is that app where for everything that you build, one feature in, a feature over here breaks. I think we've all been there. If you haven't, you will. Not just with Rails, but with any piece of software. This is what our swamp looks like. This is a graph of our Rails models and all of their active record relationships. Each edge is a relationship. We have over 700 models. Each line, each color is a different team in the organization. So we've been working on this for a year, and this is better than what it was. We still have a long way to go. In a perfect world, you would see the colors clustered a little bit closer together with just a few select relationships bridging the gaps. Working in an application like this with this many models or this size or this tangle can feel like you have your head stuck in a Kleenex box. She was okay. There are no animals harmed in the making of this presentation. So this is what our swamp looks like. It's kind of a big amorphous blob where we have some payroll over here, we've got some benefits over here, some HR functionality over here, infrastructure thrown in there. Can't really tell where one subdomain ends and the other begins based on looking at the code. And it's only so far, or it's only so long when you're working in a code base like this, where someone new shows up. We've got 100 engineers these days. Or someone kind of gets fed up with the status quo, and they say, let's extract a microservice. To that you say, cool. Okay, so we've sat down with our team. We're like, all right, what should we extract? We're going to extract the HR functionality. We think this one makes the most sense to pull out of the main application here. So we're going to Rails new up an HR v2. This is going to be the pristine application. We've learned from all of our mistakes. Everything's nice. It boots fast. We're going to do it right this time, folks. This is it. So we slowly start connecting. So we slowly start connecting the old application to the new one. Slowly porting over functionality piece by piece. Let's say there's 14 different things that we need to migrate. And as we're doing this, around halfway through, it becomes someone's full-time job just to keep track of the bookkeeping of like, okay, what's in the new one and what's in the old one, right? While you're developing this, HRV1 does not go away. It merely just sticks around. And you're continuing to get bug reports filed against the old way of doing things. So now you have this weird situation where you have to say, okay, I guess we patch the behavior in HRV1, replicate that bug in HRV2, and then patch that behavior in HRV2. And I think that's what we need to do. Finally, your product manager is breathing down your neck, saying we haven't shipped anything new to the customer in the last 6 months. You said this would be done 3 months ago. You say, I know. And you're at 13 out of 14 things migrated over, and you say, like, you know what, let's just call it quits. And then you end up with the above. Got HRV2, got old HR that just kind of sticks around. That one last piece of functionality. And so what we've actually done is I think we've actually made the problem worse. We started with the best of intentions to separate out our application cleanly. We started with a new Rails application. But what we've actually done is we've created tribal knowledge for all of our coworkers. Now, answering a simple question of, hey, where does that HR functionality live, is hard. It's complicated. It's, oh yeah, first names and last names are in HRV2, but socials are in the old place, right? Now you need to juggle this and go ask people, where does this exist? Also makes things very hard to reason about. So I'm here to say there's a better way. Wouldn't be here if I was just telling you terrible stories all day. Hopefully you say, tell me more. I'm gonna have to switch to not pacing around here. Hopefully you say, tell me more. So let's take another view of our swamp here. So we're gonna, again, stick with the same domains of HR and payroll. And we're going to just take a look at how a single piece of data moves through these, right? The vertical bars here can be different layers of your application. These can be controllers, they can be views, they can be service objects, they can be presenters, they can be mailers. Take your pick. I guess the important thing to convey here is that there are many layers in how this application interacts, like any large application probably has. And the red box up here is going to be an employee active record model. This is going to represent everything it means to be an employee within this system. Right? So as we send that email or render that pay stub, we pass that employee active record all the way through from the HR subdomain all the way down to the payroll subdomain, where payroll says employee.last. This seems pretty innocuous. In a small application, this is perfectly normal, and in fact, this is exactly what you should do. Right? Please don't go into work on Monday and say, hey, I found a great conference talk. I found all sorts of new things that we should start doing right now. Instead, talk with your team, find out if these patterns are the right ones for you. So what we want to do is we want to actually be better about separating what it means to be an employee in these two domains. So if we talk with our teams, we're actually going to understand that HR's concept of an employee is very different than payroll's concept of an employee. It's a little counterintuitive. But HR is very concerned with, okay, who are you as a person? Basically, what is your unique ID? How do you change over time? Right? Payroll, they don't care so much. It's more metadata on your pay stub, right? It's just a label that gets printed at the top of your pay stub or on your check. So we're going to set up a barrier here. In the language of domain-driven design, you might call this an anti-corruption layer, right? And so this is where this red employee active record object is no longer going to pass through. Instead, we're going to introduce a new concept that is a better model for the domain that it lives in. In this case, we'll call it a payee. Now, a payee is not going to be an active record object. Payee is just going to be a bundle of values. We call this a value object or a whole value. There's going to be a very thin amount of mapping that's going to be done to turn an employee into a payee. It's almost always going to be less information than was actually going to be on that active record God model. And then we're just going to pass that payee all the way down and print that last name on top of the pay stub. Now you might say, didn't you just move some code around and introduce some indirection? And you would be correct. That's all I did. But we've introduced an important property into the system, which is now HR can make changes to the employee active record model, drop columns, add columns, rename columns, change behavior, and they don't have to worry about how that affects the payroll subsystem or the payroll subdomain. As long as they can turn whatever their representation is into that payee value object, they're in the clear. And this is really what makes working inside of a monolith much, much easier. And so we do this over time. We repeat this over and over and over again, until eventually our two subdomains really just have these bridges between them. Right? And these bridges speak value objects. They do not speak active record objects. So you stop passing around active record objects all over the place. You stop accessing those active record objects directly. And instead, those get passed to you, or you use some other API. This can feel a little weird. Oftentimes, you'll be pulling stuff out of the database using active record or your ORM of choice, turning it into a value object, sending it across this interface, and then it might get written back to the database using active record. But by using values as this interchange mechanism, we've introduced an important piece of decoupling in our system. These two systems can now move independently, provided that they adhere to the contract. Right? So in his 2018 RailsConf keynote, DHH talked a little bit about this conceptual compression, as he called it. He said, this is the greatest strength of Rails, is its ability to take all sorts of complex concepts and compress them into very simple libraries. If you think about what active record and like the tooling around it gives you, data validation, mapping to and from the database, a migration framework, right? It gives you a lot of things. So you just have to build these by hand. With Rails, you just get them out of the box. Right? As our Rails applications grow, we've noticed that we've needed to actually pull apart a lot of those concepts and embark on some conceptual expansion. Right? It is weird to treat active record objects as private, where different subdomains don't know that they might even exist. Right? So you need to pull apart many of those layers that Rails gives you for free, but you do get to do this from a place of strength. Right? This is only after you've experienced some success and you have a successful business, and you've basically gotten to the point where the business isn't going to go away tomorrow. We now have this legacy software. Congratulations, us. Let us remind ourselves that there are two types of companies on the planet. There are those with legacy software, and there are those that don't exist. So this is a great situation to be in, but it is unfamiliar territory if you've been writing smaller Rails apps for some time. So now I want to shift gears a little bit. Now that we've talked about those two stories, talk a little about what does this look like in practice? What could you, if you were that person, don't be that person, would you do if you walked into your office Monday and said, let's do all these things? These are some considerations, or some recommendations. First one is to mind and avoid circular dependencies in your application. Circular dependencies are when two pieces of code refer to each other. We often actually don't understand how much Rails does this for us. Because for a lot of Rails, this is the default, right? This is the code that we write when we wire up a new application. A company has many employees. An employee belongs to the company. We don't even think twice about writing this. Right? At a small scale, you shouldn't. But as a large, or as your application grows, this is where the coupling starts. It starts at the model layer, and then just gets reflected everywhere else. So more and more often, we're actually asking, like, okay, do we actually need this relationship in the other way? Right? We use something called the stripe test. which is the following. If we were implementing against a Stripe API, how would we build this, right? So in this situation, employees need to know which company they belong to, but a company can kind of just be its own like thing that floats in space. It doesn't need to know about employees necessarily. So if we draw this pictorially, here's the dependency graph that we might have originally. We try to turn it into this. Okay. Recommendation number 2, use value objects to traverse edges between your subdomains. Right? This is that thing where I talked about where you turn those active record objects into just bundles of values, strings, numbers, dates, but not really anything more complicated than that, and you send them along. We do this to decouple different parts of our application and maintain those layers of our layered architecture. Let's take a look at how this looks from a code perspective. Here we have a service object that just handles the process of signing up a company. You've probably written something like this a dozen times in your day job. But we just want a service object that handles the process of what we should do after a company signs up. Here we send a welcome email, and we increment some stats counter. Company in this case is going to be an active record model, right? But this is like someone asks you to borrow $5 and you give them your house, right? Company has not only itself and all of its columns, but all of its relationships. It has a connection to the database, right? It's got all sorts of stuff that you're passing around here. And this really makes it hard to change any of these 3 components because they're all now coupled to the structure of company. So instead, we might write this a little bit different. We might just peel just what we need off of company and then pass those along to those other mailers and stats tracker in this case. And it also helps us answer a pretty interesting question, which is, okay, what information does company mailer need to actually do its job? And here we can see like, oh, actually it doesn't need much at all. It needs an email address and a first name. Why are we passing it, everything related to a company? Next recommendation, this one is brand new. We're still exploring this, but early signs are very, very promising. We're actually starting to make all active record instances private, or module private, so you can only instantiate them within a certain section of the app. Right, so this is very different from app/models where everything just gets dumped in there. This is where only certain parts of the app even know that active record is pulling this information out of the database. 4th recommendation, we recommend avoiding callbacks. Callbacks are very powerful active record lifecycle mechanisms to respond to certain events when you save a model, update a model, delete a model, so forth. It's another version of the observer pattern. Here's what a callback might look like. When we create a company, we're just going to send that welcome email again. But we've probably written this code, and then the sales team comes to us and they say, hey, you know what? We just closed a big deal. We're going to import 100 companies into the system. But we don't want to send them emails because they don't know that the deal is closed yet. And it'd just be like weird noise. So then you as a developer, you sit down and you're like, okay, look at the code. Think, okay, so I guess the Google phrase is disable Rails callbacks on models temporarily. And then you find yourself shelling into, like your 8 hosts simultaneously, monkey patching ostensibly the most important class in your entire application, trying to make sure no one deploys during that time, just so you can import a CSV of 100 companies so you don't, email them. Right? You're like, okay, there's got to be a better way. You could also change the code and introduce a flag. But a similar problem still exists. You're now a control flag would just make that problem exist forever in your code. So why is this? Basically, the company and the company mailer are very tightly coupled together, and callbacks make it very easy to do that, right? So instead, we're going to reach for a service object. This is a new service object that just handles what What should we do when we create a company here? We're going to actually create the active record model itself, and then we're going to send that welcome email. This gives us a very great point to start introducing control parameters or playing around with dependency injection to say, okay, we do want to email a company or we don't want to email a company in these certain situations. If we look at our dependency graph, this is what it might look like. And you'll notice we've introduced a third node here, this create company service object. We found as a general rule of thumb, when thinking about the structure of our applications, it's always much better to introduce a new node if it prevents introduction of a cycle. Right? You'll notice there's no bidirectional relationship between company and company mailer, but we do have a new node in our graph. We want to make sure that our directed graphs stay acyclic. We found that this leads to more flexible software that is easier to maintain. Final recommendation, move slowly. These types of projects or iterating toward a world like this takes a long time. Just to give some context, the person that I work with closely, we've closed about, I think, 200 pull requests in the last, like, 8 weeks to just slowly march toward getting 1/12 of one of these projects done. Right? It takes a very, very long time, and you need the business to kind of understand. You need to be able to tell the story like, okay, we're doing this because every time we build something over here, this thing blows up. I think we all want that to stop happening. Yes? Okay, let's try this. You're going to need a lot of trust in your team, and you're going to need a lot of buy-in from your business. Finally, to wrap up, I want to leave you with a quote from a guy named Kent Beck. Kent is known for introducing extreme programming to the world, part of the Agile software movement and manifesto. He, I believe, came up with test-driven development and JUnit and a whole host of other things that we now almost take for granted today. But he has this phrase where he says, make the hard change easy. This may be hard, then make the easy change. So when we're taming our monoliths, what we're really doing is we're making that hard change easy. We're making that change to a service-oriented architecture or microservices a much, much easier change. I think a good indication that you've done this well is extracting a microservice. It takes, like, I don't know, a week or two. For a lot of you, that should be, like almost make you feel uncomfortable or have that reaction of, that sounds impossible. I'm telling you it's possible. We've done it. It just takes a little while, and it takes a little bit of a counterintuitive thinking. So that's my talk. Thank you very much. Thanks for having me again. I'll post the slides a little bit later. But I am happy to take any question. How much time do we have? I got time. The question was, in the diagram, there was one God object that you could very clearly see at the epicenter of all of that. Which model was that? That is app/models/company.rb. If you'd like to hear more about it, you can corner me at the meet and greet tonight and buy me a beer. It's 2,000, yeah, I'm just marketing a little bit. It's about a 2,000 line long class. It used to be 3,000 lines. Yeah, over here. So the question was the point of doing all this to make moving to microservices easier, or was the point to avoid doing it at all? I don't have a clean answer to that. If you were watching this talk and you were thinking, this sounds a lot like domain-driven design, if you've ever read that big blue book, that's almost exactly what this talk is, right? So it's a little bit less about, what technology or infrastructure choices do we make. It's a little bit more about how do we make 100 engineers productive, right? Not constantly stepping on each other's toes, and provide some semblance of order. But I have found, and this makes it very nuanced to talk about, that there can be some forcing functions in different technology choices. So microservices is actually pretty interesting, because if you say we're going to go adopt microservices, you basically have to use value objects as a communication layer, because you're going to be using something like gRPC, JSON, or, over HTTP, or whatever's hot these days. And so the act of moving to microservices is actually, I think it's actually going to make your application have a much better structure sometimes. But if you're not careful, you're going to end up with a distributed monolith, and then you're worrying about like distributed transactions, and then the problem is worse, right? So I think it's helpful to know a little bit about, you know, what, where are we going and why, and then the technology choices are just that, technology choices. Does that make sense? Yep. So the question was, how do you manage all of this, especially in like a business landscape where employees are joining, employees are leaving, companies are being acquired and melted in, and then maybe once like the golden handcuffs come off, those folks are off, and so on and so forth. Yeah. So there's I started the talk about, you know, saying naming is important, right? I think there's this very powerful concept of ubiquitous language, which basically says bake the understanding into the code itself, and be very reflective of the problem space that it operates in. Because there's only so much documentation that you can do where like the documentation will start to drift. And then at the end of the day, the truth is really, what does the code do today? So if the code is clean and it's a good representation of the domain, and it uses the same language that the domain experts use. So for us, it's a lot of like payroll compliance folks. We found that can smooth those like brain drain transitions a little bit more. Does that help? Do you have a follow-up? Oh. Okay, got time for one more. About all the way in the back there. Question was, what are the determining factors when you switch to this service-based architecture? You can use you can be like very like metrics driven, right? You can say, okay, for every feature that we release, how many bugs do we introduce? How many times when we fix a bug does another one show up or get reported? That does require a lot of operational overhead to just measure that stuff. I think it's okay to just go with, when are the developers on my team so frustrated? And like you can see them frustrated, and you know, I work in this day in and day out. When are they so frustrated that they just can't be productive anymore? Right? For these reasons, where they have to keep the whole world and then some in their head just to make a very small inconsequential change. So yeah, whether it's bug introduction rates, whether it's estimates being like wildly out of whack, where something you expect to take 3 days takes 3 weeks, right? And that's a routine occurrence. Or just more qualitative, like folks are frustrated. So it's a mix. It'll depend. Cool. All right, thanks.